All right, in example 3, it says to rewrite radical functions to identify transformations. So notice now this multiplier, this 9 and then the 4 in B, inside the square root. So what we're going to do here is we're going to apply what we did in the last section. We're going to split up 9 times x, and then since we can take the square root of 9, we're going to bring it out as a 3. Square root of 9 is 3. We want to always do this when we can because it's much easier to apply a dilation vertically to the outputs than it is on the inside to the inputs. So this 3 actually triples the y values. Okay, so I would call it a vertical stretch by a factor of 3. Now, if you wanted to think of it as a horizontal compression instead, you certainly could. Either way, you could look at it either way. However, the factor wouldn't be by 9 or it's going to be by 1/9. So notice the difference between the scale factor here. 1/9 is how it compresses horizontally. 3 is how it stretches vertically. It's not a 1-to-1 ratio between the two because you have to square root it to see the relationship. Okay? And that's really all they asked us to do there. They didn't ask us to actually graph it. You could certainly put it into Desmos or your calculator just to confirm that that's how it behaves. And the next one, there's an added layer here. You want to, and we actually did this in Unit 2 with, I think it was with parabolas. So if you have a multiplier inside the parent function like this 4, you want to separate it from the x, and any horizontal translation like this plus 16, you want to factor the 4 away from it and call it 4 times x plus 4. So we can correctly see that it actually shifts left 4. Not left 16, you know how you might think, but when you first look at this, it's actually left 4, up 7. Notice the 7 doesn't get affected by this business going on inside the square root. As far as the dilation is concerned, we're going to do the same thing we did up here with the 9. Take the square root of it. Since the square root of this 4 comes out as a 2, we can see all the proper transformations now. We have a left 4, up 7, and stretch vertically by 2. Okay? Those are all the transformations involved here. So why don't you complete the triads down here. Next for homework, and we will go over these tomorrow in class. This one's a little tricky with the 12. Okay. In fact, now that I think about it, skip this one. We'll do this one together tomorrow, okay? Do this one together. Try this one